Hello, and welcome to the Cozy Curiosity channel. Tonight, we're embarking on a gentle journey beyond our world, exploring 100 fascinating facts about space travel. From the first brave souls who dared to leave Earth's embrace, to the dreams of distant worlds we've yet to touch, humanity's reach into the cosmos tells a story of courage, curiosity, and wonder. So before you get comfortable, take a moment to like the video and subscribe. It helps other sleepy souls find their way here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now settle in, let your breathing slow, and allow your mind to drift among the stars as we trace the arc of our adventures beyond the sky. Whether you're here to learn, to relax, or simply to fall asleep to the rhythm of discovery, these calming stories will guide you through the greatest journey our species has ever undertaken. Let's begin. Time tens. The first human-made object to reach space was a Nazi V-2 rocket in 1944. Long before astronauts or satellites, a military weapon accidentally became humanity's first ambassador to space. On October 3rd, 1942, a V-2 rocket launched from Germany crossed the Kármán line, the invisible boundary 100 kilometers above Earth's surface that marks where atmosphere ends and space begins. Engineers weren't trying to explore the cosmos. They were developing weapons for war. But in doing so, they proved that space was reachable. The rocket climbed higher than any human creation had ever traveled, touching the edge of darkness before falling back to Earth. It was a grim beginning to space exploration, a reminder that many of our greatest achievements emerge from complex circumstances. Yet that brief journey upward planted a seed, showing that the realm beyond our sky wasn't forever out of reach, but waiting for us to claim it. Laika the dog became the first living creature to orbit Earth in 1957. Before humans could risk the journey, scientists needed to understand whether life could survive in space. The Soviet Union chose a small street dog from Moscow, trained her, and placed her inside Sputnik 2. On November 3rd, 1957, Laika lifted off, her heartbeat monitored from the ground as she circled the planet. She proved that a living being could endure the violence of launch, the weightlessness of orbit, and the strange silence beyond the atmosphere. Sadly, Laika didn't return home. The technology to bring her back safely didn't exist yet. Her sacrifice opened the door for human spaceflight, showing that flesh and blood could survive where only metal and fuel had gone before. Today, memorials honor her bravery, a small dog who became a pioneer without choice, but whose journey made all future journeys possible. Yuri Gagarin became the first human in space on April 12, 1961, and Gagarin climbed into the Vostok 1 capsule. No one knew for certain whether a human mind could function in the weightlessness of orbit, or whether the body would fail under such unnatural conditions. He launched from Kazakhstan, ascending through the atmosphere as millions watched from below. The flight lasted only 108 minutes, one complete orbit of Earth. But in that brief time, he saw what no human had ever seen: the curve of our planet against the black void, the thinness of our atmosphere, the breathtaking fragility of home. He radioed back simple observations, describing the beauty and the strangeness. When he returned, landing safely in a field, he had transformed humanity's relationship with the cosmos. We were no longer earthbound. We had touched the stars and returned to tell the story. The Apollo 11 mission put the first humans on the moon in 1969. For thousands of years, the moon hung in our sky as an untouchable mystery, a silver companion we could only dream about. Then, on July 20th, 1969, Neil Armstrong and Buzz Aldrin descended in the lunar module Eagle, touching down on the Sea of Tranquility while Michael Collins orbited above. Armstrong's first step onto the dusty surface marked the culmination of centuries of wandering and a decade of focused effort. The landscape was stark, grey and silent, covered in fine powder that clung to their suits. They planted a flag, collected rocks, and took photographs that would define an era. For a brief moment, humanity stood on another world. The achievement wasn't just technical, it was philosophical, proving that the barriers separating us from the cosmos were not permanent, but waiting to be crossed. Spacesuits function as personal spacecraft protecting astronauts from the void. When you step outside a spacecraft in orbit, you're not just stepping into air that's too thin to breathe. You're entering an environment that wants to kill you instantly. The vacuum of space would boil the fluids in your body. Radiation would penetrate your cells. Temperatures swing from extreme heat in sunlight to extreme cold in shadow. A spacesuit prevents all of this. It maintains pressure around your body, circulates oxygen, regulates temperature, and shields you from radiation. It's equipped with communication systems, a drink bag, and even a maximum absorbency garment for waste. Astronauts spend hours in these suits during spacewalks, performing repairs and experiments while floating in the void. The suit becomes a tiny bubble of Earth, a protective shell carrying everything necessary to keep fragile human life intact in the most hostile environment imaginable. The International Space Station orbits Earth every 90 minutes at over 27,000 kilometers per hour. High above the planet, moving faster than a speeding bullet, the International Space Station traces a path around Earth 16 times each day. It travels so quickly that astronauts aboard experience a sunrise or sunset every 45 minutes, watching the Terminator line sweep across continents and oceans in an endless rhythm. The station itself is a marvel of cooperation, assembled piece by piece over more than a decade by space agencies from around the world. Inside, astronauts float through modules, conducting experiments in microgravity, growing plants, studying their own bodies, and gazing down at the world below. The station represents humanity's only permanent presence beyond Earth, a small outpost of warmth and life hurtling through the cold void, proving that we can not only visit space, but live there. Astronauts grow taller in space due to the absence of gravity. On Earth, gravity constantly compresses your spine, pressing the vertebrae together and squeezing the soft discs in between. In space, without that downward force, your spine stretches out, decompressing like a spring that's been released. Astronauts can grow up to 5 centimeters taller during long missions, a strange and unexpected side effect of weightlessness. This elongation can cause back pain as muscles and ligaments adjust to the new length. When astronauts return to Earth, gravity reasserts itself, compressing the spine back to its normal height within weeks. It's a reminder that our bodies evolved for Earth-specific conditions, shaped by millions of years under the gentle but constant pull of gravity, and that removing even one familiar force creates cascading changes we're still learning to understand and manage. The Moon is slowly drifting away from Earth at about 3.8 centimeters per year. Every year, the Moon's orbit carries it slightly farther from our planet, a slow farewell measured in millimeters and centimeters. This drift happens because of tidal forces. The Moon pulls on Earth's oceans, creating tides. and Earth pulls back, gradually transferring energy that pushes the moon outward. Billions of years ago, the moon loomed much larger in our sky, orbiting closer and faster. In the distant future, it will appear smaller, its influence on our tides weaker. This gradual separation won't affect us in our lifetimes, or even in countless generations. But it's a reminder that nothing in the cosmos is truly static. Even the relationship between Earth and its ancient companion is slowly, quietly changing, an embrace loosening over deep time. Space is completely silent because there's no air to carry sound waves. On Earth, sound travels through air, vibrating molecules that bump into each other and carry the wave forward to your ears. In the vacuum of space, there are no molecules to vibrate, no medium for sound to travel through. If an explosion happens outside your spacecraft, you won't hear it. If another ship passes nearby, it moves in absolute silence. Astronauts communicate through radios because radio waves, unlike sound waves, don't need air. They travel as electromagnetic radiation. This silence is profound and unsettling. In films, space battles roar with noise, but in reality, the cosmos is quiet beyond imagining. Stars burn, galaxies collide, rockets fire, and all of it unfolds in a vast eternal hush. The only sounds astronauts hear are the ones inside their suits, their own breathing, the hum of equipment, the beating of their hearts. The first meal eaten in space was beef and liver paste squeezed from a tube. When Yuri Gagarin orbited Earth, he carried with him tubes of pureed food, not because it was appetizing, but because scientists didn't know if humans could swallow in zero gravity. They worried that without gravity to help food travel down the esophagus, eating might be impossible or dangerous. Gagarin proved them wrong, successfully consuming beef paste, chocolate sauce, and other semi-liquid meals during his flight. Later missions experimented with different foods, improving taste and variety. Today, astronauts enjoy a surprisingly diverse menu, from shrimp cocktail to ice cream, carefully packaged to prevent crumbs and spills that could float away and damage equipment. Eating in space has evolved from a scientific experiment into a daily ritual, a small but essential comfort that helps astronauts feel human while living in an environment designed to remind them they're far from home. Tears don't fall in space. They form a ball of water on your face. Crying in microgravity is a strange experience. On Earth, tears well up in your eyes and then run down your cheeks, pulled by gravity. In space, there's no down for them to fall toward. Instead, tears accumulate around your eyes, forming a small blob of salty water that clings to your face through surface tension. If you produce enough tears, the blob can grow larger, sometimes spreading across your face, or even stinging your other eye. Astronauts have described it as uncomfortable and disorienting. Eventually, you have to wipe the tears away with a towel, breaking the surface tension and absorbing the liquid. It's one of countless small ways that space changes even the most basic human experiences, transforming familiar actions into something strange, reminding astronauts that they're living in a place where the ordinary rules no longer apply. The footprints left on the moon by Apollo astronauts could last millions of years. The moon has no atmosphere, no wind, no rain, no erosion from weather. The footprints pressed into the lunar dust in 1969 remain as crisp today as they were when Armstrong and Aldrin walked there. Over time, micrometeorites, tiny grains of space dust, will slowly bombard the surface. and cosmic rays will gradually alter the regolith. But these processes unfold over geological timescales. The footprints might endure for millions of years, silent markers of humanity's first steps on another world. They're a monument without intention, preserved not by design, but by the moon's stillness. Long after the spacecraft that carried those astronauts have crumbled, long after the nations that sent them have faded into history, those footprints will remain, testament to the day we left Earth and walked somewhere new. Spacecraft use gravitational slingshots to gain speed without using extra fuel. When a spacecraft approaches a planet, it can use the planet's gravity to accelerate, stealing a tiny fraction of the planet's orbital momentum and redirecting its path. This maneuver, called a gravity assist or gravitational slingshot, allows missions to reach distant destinations faster and with less fuel than would otherwise be possible. The Voyager probes used multiple gravity assists, swinging past Jupiter and Saturn, to gain the speed needed to reach Uranus, Neptune, and eventually interstellar space. The spacecraft doesn't actually touch the planet. It simply falls toward it, curves around, and is flung outward with increased velocity. It's a beautiful application of physics, turning the gravity of worlds into free propulsion, allowing us to explore the outer solar system without carrying impossible amounts of fuel. The Voyager 1 spacecraft is now in interstellar space, over 24 billion kilometers from Earth. Launched in 1977, Voyager 1 completed its primary mission of exploring Jupiter and Saturn, then kept going, climbing outward through the solar system. In 2012, it crossed the heliopause, the boundary where the sun's influence fades and interstellar space begins. It's now farther from Earth than any other human-made object, traveling through a region no spacecraft has ever visited. Its cameras are turned off to save power, but its instruments still send back data about cosmic rays and magnetic fields. The signals take over 22 hours to reach Earth, crossing the vast emptiness at the speed of light. Voyager carries a golden record, a message from humanity to any civilization that might find it in the distant future. It's a lonely ambassador, drifting outward into the dark, carrying our hopes and our greetings to the stars. Astronauts lose bone density in space at a rate similar to osteoporosis patients on Earth. In microgravity, your bones don't have to support your weight anymore. Without that constant stress, they begin to weaken. Astronauts can lose up to 1 to 2% of their bone mass per month, primarily in the hips, spine, and legs. To combat this, they exercise for hours each day, using specially designed resistance machines that simulate weight-bearing activity. Even with rigorous exercise, some bone loss is unavoidable, and recovery after returning to Earth can take months or even years. This is one of the major challenges for long-duration spaceflight. A trip to Mars could last years, and astronauts would arrive with significantly weakened bones, potentially making them vulnerable to fractures. Scientists are studying medications, dietary supplements, and new exercise protocols to protect astronaut health. Because if we want to explore farther, we need to solve the problem of fragile bones in the weightless dark. The temperature in space can vary wildly, from extremely hot to extremely cold. In the vacuum of space, temperature behaves strangely. There's no air to conduct heat, so your temperature depends entirely on radiation. If you're in direct sunlight, facing the sun without any atmosphere to filter its rays, temperatures can reach over 120 degrees Celsius. But in shadow, away from any light source, temperatures plummet to near absolute zero, around -270 degrees Celsius. Spacecraft and spacesuits are designed with insulation and reflective layers to manage these extremes, regulating temperature to keep astronauts and equipment safe. On the Moon, the day side bakes under sunlight for 2 weeks straight, while the night side freezes in darkness for another 2 weeks. This extreme fluctuation is one more challenge of living beyond Earth's protective embrace, where even something as simple as temperature becomes a matter of life and death. The first space tourists paid millions to visit the International Space Station. In 2001, American businessman Dennis Tito became the first private citizen to pay for a trip to space. He spent nearly 8 days aboard the ISS, floating through the modules, gazing out the windows, and experiencing the wonder of weightlessness. His journey cost a reported $20 million, a fortune, but for him, worth every cent. Since then, several other space tourists have followed, each paying tens of millions for the privilege. These trips represent the earliest steps toward making space accessible beyond government astronauts and trained professionals. Companies are now developing commercial spacecraft designed specifically for tourism, aiming to lower costs and open the experience to more people. The dream is that one day, space travel won't be reserved for the elite or the specially trained, but available to anyone who wants to see Earth from above. NASA's Deep Space Network allows us to communicate with spacecraft across the solar system. Scattered across the globe in California, Spain, and Australia are massive radio antennas, each one precisely positioned so that as Earth rotates, at least one antenna always faces any given spacecraft. These antennas form NASA's Deep Space Network, a communication system that sends commands to distant probes and receives their faint signals back. The farther a spacecraft travels, the weaker its signal becomes, spreading out across space. By the time Voyager's signal reaches Earth, it's incredibly faint, but the Deep Space Network can still detect it, interpreting the whispers of data sent from billions of kilometers away. This network is humanity's voice, reaching across the void, ensuring that no matter how far our machines travel, we can still hear them, and they can still hear us, maintaining a fragile thread of connection across the immense distances of space. Space smells like burnt metal, gunpowder, and seared steak, according to astronauts. You can't smell space directly because you can't remove your helmet in vacuum, but astronauts report a distinct odor that clings to their suits and equipment after a spacewalk. When they re-enter the airlock and the chamber repressurizes, they notice the smell, a sharp, metallic, slightly sweet scent, often compared to burnt steak or welding fumes. The source is likely high-energy particles and radiation interacting with the suit materials, or polycyclic aromatic hydrocarbons, complex molecules that form in space. It's a strange and unexpected detail, a sensory reminder that space isn't empty nothingness, but filled with particles, energy, and chemistry we don't fully understand. The smell fades quickly, but for those who've experienced it, it's an indelible memory, the scent of the cosmos clinging briefly to the fabric of their suits. The concept of a space elevator could revolutionize access to orbit without rockets. Imagine a cable stretching from Earth's surface to a satellite in geostationary orbit, 36,000 kilometers above. Elevators could climb this cable, carrying cargo and people into space without the need for massive rockets or fuel. It sounds like science fiction, but the physics are sound. The challenge is materials. We need a cable strong enough to support its own weight without snapping, and current materials like steel aren't strong enough. Carbon nanotubes offer potential, but manufacturing them at the necessary scale remains far beyond our capabilities. If we ever build a space elevator, it would transform spaceflight from an expensive, dangerous rocket launch into a routine elevator ride, making orbit accessible in ways we can barely imagine. For now, it remains a dream, but one grounded in real science, waiting for the technology to catch up. Elon Musk's SpaceX became the first private company to send astronauts to the ISS in 2020. For decades, only government agencies like NASA and Roscosmos launched humans into space. Then, on May 30th, 2020, 2 NASA astronauts climbed into a SpaceX Crew Dragon capsule, lifted off atop a Falcon 9 rocket, and successfully docked with the ISS. It marked a turning point, the beginning of commercial human spaceflight. SpaceX, founded with the ambitious goal of making humanity a multi-planetary species, proved that private companies could achieve what was once the exclusive domain of nations. Since then, multiple crewed missions have followed, ferrying astronauts to the station and back. This shift opens possibilities. More players in space means more innovation, more missions, and potentially lower costs. It's a new era where space travel is no longer just the work of governments, but the frontier of entrepreneurial ambition. Astronauts aboard the ISS experience 16 sunrises and sunsets every day. Orbiting Earth every 90 minutes, astronauts watch the sun rise and set in an endless cycle. The Terminator line, the boundary between day and night, sweeps across the planet beneath them. They see sunlight catch the edge of the atmosphere, glowing in brilliant oranges and blues, before darkness falls again. This constant rhythm disrupts normal sleep patterns, so the station uses blackout shades and scheduled lighting to simulate a 24-hour day. But even with those measures, the experience is disorienting, a reminder that they're living outside the natural cycles that governed human life for millennia. Some astronauts find it beautiful, mesmerized by the endless parade of dawns. Others find it exhausting, longing for the steady, predictable rhythm of a single sunrise and a single sunset, the way things are supposed to be. The Hubble Space Telescope has transformed our understanding of the universe from its orbit. Launched in 1990, Hubble orbits Earth above the distorting effects of the atmosphere, capturing images of unparalleled clarity. It has photographed distant galaxies, dying stars, nebulae where new stars are born, and planets orbiting other suns. Its images are not just scientifically valuable, they're stunningly beautiful, revealing the cosmos in vivid detail. Hubble helped determine the rate of the universe's expansion, discovered that nearly every galaxy has a supermassive black hole at its center, and provided evidence for dark energy. Despite its age, it continues to operate, having been repaired and upgraded by astronauts during 5 servicing missions. Hubble is more than a telescope. It's humanity's eye in the sky, showing us the universe as we've never seen it before, and reminding us how much beauty exists beyond our small world. The Mars rovers, Spirit, Opportunity, and Curiosity have explored the red planet for years. Robots have roamed the surface of Mars, analyzing rocks, snapping photographs and drilling into the soil, searching for signs that Mars once had the conditions necessary for life. Spirit and Opportunity, twin rovers launched in 2003, far exceeded their planned 90-day missions, with Opportunity operating for nearly 15 years. Curiosity, which landed in 2012, continues exploring today, climbing mountains and studying ancient lake beds. These rovers move slowly, sometimes only meters per day, carefully navigating around obstacles and analyzing their surroundings. They've discovered evidence of ancient water, organic molecules, and landscapes shaped by rivers and lakes that dried up billions of years ago. Each rover is a robotic geologist, our eyes and hands on a distant world, patiently uncovering Mars's secrets, one rock at a time. Water behaves strangely in space, forming floating spheres instead of puddles or streams. Without gravity to pull it downward, water in microgravity clings together through surface tension, forming perfect spheres that float freely. Astronauts can create wobbling balls of water that drift through the cabin, capturing light and reflecting their surroundings. If you push a droplet, it might break apart into smaller spheres or merge with another, absorbing it like a slow-motion collision. Drinking water requires special pouches or bags with straws because you can't pour liquid into a cup. It would simply float away. Washing is similarly complicated. Astronauts use damp towels and no-rinse soap because showers would create floating droplets that could damage equipment. Water's strange behavior in space is beautiful and fascinating, but it also makes everyday tasks far more complicated than they are on Earth. The Sun accounts for 99.86% of the mass in our solar system. Everything else, all the planets, moons, asteroids, comets, and dust combined, makes up just 0.14%. The Sun is overwhelmingly dominant, a massive sphere of burning hydrogen and helium that holds the entire solar system in its gravitational grip. Earth, Jupiter, Saturn, all of them are tiny in comparison, orbiting around this enormous central fire. The Sun's gravity reaches across billions of kilometers, keeping even distant Pluto in a slow elliptical orbit. Without the Sun, there would be no solar system, just a scattered collection of frozen rocks drifting through space. Its light warms our world. Its energy powers nearly every process on Earth, and its gravity keeps us anchored in place. The Sun is the anchor, the source, the heart of everything we call home. Saturn's rings are made of billions of chunks of ice and rock, some as small as dust, others as large as houses. From a distance, Saturn's rings look like smooth, solid disks. But up close, they're revealed to be countless individual pieces orbiting the planet. These fragments range from microscopic grains to boulders the size of buildings, all shimmering with ice. The rings are surprisingly thin, only about 10 meters thick in some places, despite being hundreds of thousands of kilometers wide. Scientists believe they might be the remnants of a shattered moon, torn apart by Saturn's gravity, or perhaps leftover material from the planet's formation. The rings aren't permanent. They're slowly spiraling inward, raining down onto Saturn's atmosphere. In about 100 million years, they may be gone entirely, making our era one of the few times in Saturn's history when these beautiful rings exist. The James Webb Space Telescope can see farther into the universe than any telescope before it. Launched in 2021, the James Webb Space Telescope orbits the Sun at a point called L2, about 1.5 million kilometers from Earth. Its massive mirror collects infrared light, allowing it to see through cosmic dust and peer back to the earliest galaxies, those that formed just a few hundred million years after the Big Bang. Webb's images reveal stars being born inside nebulae, exoplanets with atmospheres we can analyze, and Galaxies so distant their light has been traveling toward us for over 13 billion years. It's the successor to Hubble, designed to answer questions about the origins of the universe, the formation of stars and galaxies, and the potential for life on other worlds. Webb represents the cutting edge of astronomy, a tool that allows us to see not just farther, but deeper into time itself. Rocket launches require precisely timed launch windows to reach their destinations. You can't just launch a rocket whenever you feel like it. To reach the ISS, rendezvous with another spacecraft, or travel to another planet, you need to launch at exactly the right moment when Earth's rotation, the target's position, and the rocket's trajectory all align. These launch windows can be as short as a few minutes. Miss the window, and you might have to wait days, weeks, or even months for the next opportunity. For missions to Mars, the launch window opens only about every 26 months when Earth and Mars are positioned favorably in their orbits. This constraint requires meticulous planning, weather predictions, and readiness to abort if conditions aren't perfect. Space travel is not spontaneous. It's choreographed with precision. Every launch a carefully calculated dance with the mechanics of the solar system. The concept of terraforming Mars involves transforming it into an Earth-like world. Mars is cold, dry, and has a thin atmosphere, mostly made of carbon dioxide. But some scientists believe we could change that. Terraforming would involve releasing greenhouse gases to warm the planet, melting polar ice caps to create liquid water, and introducing microbes, plants, and eventually animals to build a breathable atmosphere. It would take centuries, perhaps millennia, and the technology doesn't exist yet. The challenges are enormous. Mars lacks a magnetic field to protect against radiation, and its gravity is only 1/3 of Earth's. Still, the dream persists. Transforming Mars into a second Earth would ensure humanity's survival, giving us a backup world if something catastrophic happens to our home. It's a monumental vision, one that stretches our imagination and pushes the boundaries of what might be possible with determination, time, and technology. Dark matter makes up about 85% of the matter in the universe, yet we can't see it. Galaxies spin too fast. Gravity alone from the visible stars and gas shouldn't be enough to hold them together, yet they don't fly apart. Something invisible must be providing extra mass, extra gravity. That something is dark matter, and it's everywhere. It doesn't emit, absorb, or reflect light, making it completely invisible to telescopes. We only know it exists because of its gravitational effects on visible matter. Despite decades of searching, scientists still don't know what dark matter is made of. It might be exotic particles that rarely interact with ordinary matter, or something entirely unexpected. Understanding dark matter is one of the greatest challenges in physics, a mystery that reminds us how little we truly know about the universe we inhabit, how much remains hidden in the dark spaces between the stars. Astronauts use the term Earthrise to describe the stunning view of Earth appearing above the lunar horizon. During the Apollo 8 mission in 1968, astronauts orbiting the Moon witnessed something no human had seen before: Earth rising above the barren, grey lunar landscape. The photograph they captured, called Earthrise, became one of the most iconic images in history. It shows our planet as a fragile, colourful sphere hanging in the void, a stark contrast to the lifeless desolation of the Moon. That image changed perspectives, reminding people how small and vulnerable Earth is, how precious and rare. It helped inspire the environmental movement, giving humanity a new view of itself, not as separate nations or continents, but as a single world, alone in the vastness of space, deserving of care and protection. The speed of light is the cosmic speed limit. Nothing can travel faster. Light moves at approximately 299,792 kilometers per second, and according to Einstein's theory of relativity, nothing with mass can reach or exceed this speed. This limit has profound implications for space travel. Even at the speed of light, it takes over 4 years to reach the nearest star system, Alpha Centauri. With our current technology, spacecraft travel far slower, meaning journeys to other stars would take tens of thousands of years. Some scientists speculate about theoretical concepts like warp drives or wormholes that might circumvent this limit, but these remain purely speculative. For now, the speed of light stands as an unyielding barrier, a cosmic rule that constrains how quickly we can explore and reminds us that the universe is unimaginably vast, with distances that dwarf our fastest machines. Microgravity affects how flames burn, creating spherical balls of fire instead of the pointed flames we see on Earth. On Earth, hot air rises because it's less dense than cool air, creating the familiar teardrop shape of a candle flame. Oh, in microgravity, there's no up for hot air to rise toward, so flames behave differently. They form small spherical balls, burning evenly in all directions. These spheres are often blue instead of orange, burning at a lower temperature and using less oxygen. Studying combustion in space helps scientists understand fire behavior in ways impossible on Earth, with applications for designing safer spacecraft and improving fuel efficiency. It's one of many examples of how removing gravity reveals hidden aspects of familiar processes, showing us that even something as simple as fire changes when you take away the pull of Earth. The Parker Solar Probe is the fastest human-made object, traveling over 700,000 kilometers per hour. Launched in 2018, the Parker Solar Probe is on a mission to study the Sun up close, diving repeatedly into its outer atmosphere, the corona. To reach the Sun, it uses gravity assists from Venus, swinging past the planet multiple times to slow down and drop closer to our star. At its closest approach, the probe travels at astonishing speeds, fast enough to fly from New York to Tokyo in less than a minute. It endures temperatures exceeding 1,300 degrees Celsius, protected by a special heat shield that keeps its instruments cool. The data it collects helps scientists understand solar wind, magnetic fields, and the processes that heat the corona to millions of degrees. It's humanity's closest look at the Sun, a daring mission into the heart of our solar system's furnace. Jupiter's Great Red Spot is a storm larger than Earth that has raged for centuries. When astronomers first observed Jupiter through telescopes in the 1600s, they noticed a massive red oval on its surface. That storm, now called the Great Red Spot, has been spinning ever since, a swirling vortex of clouds and lightning large enough to swallow multiple Earths. Wind speeds inside reach over 400 kilometers per hour, and the storm shows no signs of stopping, though it has been shrinking slowly over the past century. The red color likely comes from complex chemicals in Jupiter's atmosphere, reacting to sunlight and radiation. This storm is a reminder of the sheer scale and violence of weather on gas giant planets. where the absence of solid ground allows storms to grow and persist in ways impossible on Earth. Astronauts on the ISS contribute to experiments in biology, physics, medicine, and materials science. The microgravity environment of the space station allows researchers to study phenomena that are impossible to observe on Earth. Flames burn differently, crystals grow more perfectly, and fluids behave in unexpected ways. Biologists grow plants to understand how they might provide food on long missions. Medical researchers study how the human body changes without gravity. Insights that help treat osteoporosis and muscle atrophy on Earth. Materials scientists create new alloys and compounds that form differently in weightlessness. The ISS is a laboratory like no other, a place where removing gravity reveals hidden properties of matter and life. The knowledge gained there doesn't just help us explore space, it improves life on Earth, proving that the pursuit of the stars benefits everyone. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are called gas giants because they lack solid surfaces. If you tried to land on Jupiter, you would find no ground to stand on. You descend through layers of thickening gas and clouds, the pressure and temperature increasing until the hydrogen gas becomes liquid, and deeper still, possibly a core of rock and metal. But there's no distinct surface, no place where atmosphere ends and solid ground begins. These planets are mostly hydrogen and helium, the lightest elements, gathered into enormous spheres by their own gravity. Their size is staggering. Jupiter alone is more massive than all the other planets combined. They're alien worlds, utterly unlike Earth, beautiful from a distance with their swirling clouds and colourful bands, but inhospitable, violent, and strange. The coldest place in the solar system is not Pluto, but the shadowed craters at the moon's south pole. In permanently shadowed craters near the moon's poles, sunlight never reaches. These dark pockets have remained frozen for billions of years, and temperatures there drop to around -240 degrees Celsius, colder than anywhere on Pluto's surface. Scientists believe these craters contain water ice, trapped in the darkness and preserved in the cold. This ice is valuable. It could provide water for future lunar bases, be split into oxygen and hydrogen for breathing and fuel, and support long-term human presence on the moon. Discovering these frozen reservoirs has reignited interest in lunar exploration, with plans to send missions specifically to these craters to study and potentially harvest the ice, turning the moon's coldest places into oases for future explorers. Rocket fuel is often a combination of liquid oxygen and liquid hydrogen, which combust with explosive force. Inside a rocket's engines, super-cold liquid hydrogen and liquid oxygen are mixed and ignited. The reaction is violent and powerful, releasing enormous energy that propels the rocket upward. These propellants are stored at cryogenic temperatures below -180 degrees Celsius in insulated tanks. The engines must ignite them precisely, controlling the flow to produce steady, sustained thrust. Other rockets use different fuels, some solid, some hypergolic mixtures that ignite on contact, but the principle is the same: rapid combustion that converts chemical energy into motion. The roar of a rocket launch, the flames and smoke are the visible result of this controlled explosion, a demonstration of humanity's ability to harness chemistry and physics to escape the pull of our planet. The asteroid belt between Mars and Jupiter contains millions of rocky fragments, remnants from the solar system's formation. When you imagine the asteroid belt, You might picture a dense field of tumbling rocks, but in reality, the asteroids are spread across a vast region of space, separated by millions of kilometers. Most are small, just a few meters across, though some, like Ceres, are large enough to be classified as dwarf planets. The total mass of all the asteroids combined is less than that of Earth's moon. These objects are leftovers, pieces that never coalesced into a planet, disrupted by Jupiter's powerful gravity. Some asteroids are made of metal, others of rock or ice. A few have been visited by spacecraft, revealing rugged, cratered surfaces. They're a window into the early solar system, frozen in time, waiting to tell their story. SpaceX's Starship aims to be the first fully reusable spacecraft capable of carrying humans to Mars. Traditional rockets are mostly expendable, their stages discarded after launch. Starship is different, designed to land back on Earth after delivering its payload, refuel, and launch again. It's enormous, standing taller than the Statue of Liberty, capable of carrying over 100 tons to orbit or 100 passengers on interplanetary journeys. Elon Musk envisions fleets of starships ferrying people and cargo to Mars, building a self-sustaining city on another planet. The engineering challenges are immense, but early test flights have shown promise. If successful, Starship could revolutionize space travel, making it routine and affordable in ways previously unimaginable. It represents a bold vision, the belief that humanity's future lies not just on Earth, but among the planets, and that we have the will and the technology to make that future real. The moon's surface is covered in a fine, powdery dust called regolith, created by billions of years of meteorite impact. Without an atmosphere to slow them down, meteorites strike the moon at full speed, shattering rocks and creating clouds of fine particles. Over eons, the surface has been pulverized into a layer of grey dust that covers everything. This regolith is sharp and abrasive, clinging to suits and equipment. Apollo astronauts found it troublesome. It got into seals, scratched visors, and was impossible to clean off completely. Some even reported that it smelled like gunpowder. The dust is also electrostatically charged, sticking to surfaces and floating in the low gravity. Future lunar missions will need better ways to manage regolith, perhaps using magnetic or electrostatic systems to repel it, because the moon's dust is more than just a nuisance. It's a challenge that must be overcome to establish a lasting human presence there. Venus is the hottest planet in the solar system, despite being farther from the Sun than Mercury. Mercury is closer to the Sun, but it lacks an atmosphere to trap heat, so temperatures swing wildly between scorching days and freezing nights. Venus, however, has a thick atmosphere made mostly of carbon dioxide, creating a runaway greenhouse effect. The surface temperature reaches about 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is 90 times greater than Earth's, equivalent to being a kilometer underwater. Sulfuric acid clouds blanket the sky, and winds in the upper atmosphere race around the planet at hundreds of kilometers per hour. Venus is a hellish world, a cautionary tale of what happens when greenhouse gases trap heat too effectively. Studying Venus helps scientists understand climate change and atmospheric dynamics, showing us what Earth might become if we're not careful. The Sun will eventually expand into a red giant, engulfing Mercury, Venus, and possibly Earth. The Sun is middle-aged, about 6 billion years old, with another 5 billion years of stable burning ahead. But eventually, it will exhaust the hydrogen in its core, and begin fusing helium. When that happens, the sun will expand dramatically, swelling into a red giant hundreds of times its current size. Its outer layers will reach past Mercury's orbit, perhaps even Earth's, scorching or swallowing the inner planets. Earth's oceans will boil away, the atmosphere will be stripped, and life as we know it will end. But this won't happen for billions of years, giving humanity, if we survive that long, ample time to leave. It's a distant fate, but a reminder that even the sun, our constant companion, is temporary, destined to change and fade, taking the planets with it. Astronauts aboard the ISS must exercise for 2 hours every day to counteract muscle and bone loss. Without gravity, muscles don't have to work as hard. You don't need strong legs to walk, you just float. Over time, muscles atrophy, especially in the legs and back. Bones weaken as well, losing density without the stress of supporting body weight. To prevent this, astronauts use specialized equipment, resistance machines that simulate weightlifting, treadmills with harnesses to provide resistance, and stationary bikes. Even with rigorous daily exercise, some loss is unavoidable. When they return to Earth, astronauts need weeks or months of rehabilitation to rebuild strength and adapt to gravity again. This is one of the biggest challenges for long-duration missions. If we want to send people to Mars and bring them back healthy, we need better ways to keep their bodies strong in the weightlessness of space. The concept of a space colony has been explored through designs like the O'Neill cylinder, a rotating habitat that creates artificial gravity. Imagine a massive cylinder, several kilometers long and wide, rotating slowly in space. The rotation creates centrifugal force, pressing everything against the inner surface, simulating gravity. Inside, you could build parks, homes, farms, entire communities living on the inner wall, with windows letting in sunlight or artificial lighting, mimicking Earth's day-night cycle. Physicist Gerard O'Neill proposed this design in the 1970s as a way to house millions of people off Earth. It's technically possible, with enough resources and engineering, but building one would be an enormous undertaking. Still, the vision endures. A future where humans don't just visit space, but live there permanently, in habitats that feel like home, spinning gently among the stars. Saturn's moon Titan has lakes and rivers of liquid methane and ethane instead of water. Titan is the only moon in the solar system with a thick atmosphere, and beneath its orange, hazy skies, methane rain falls from clouds, carving rivers and filling lakes. The temperature is so cold, around minus 180 degrees Celsius, that methane and ethane exist as liquids, playing the role that water plays on Earth. Titan's surface features mountains, dunes, and even shorelines shaped by these hydrocarbon seas. The Cassini mission dropped the Huygens probe onto Titan's surface, revealing a strange alien world that's eerily similar to Earth in some ways, with weather, erosion, and seasonal cycles, but made of entirely different substances. Titan is one of the most intriguing places in the solar system, a moon where life as we know it couldn't survive, but where chemistry creates a landscape hauntingly familiar. The Fermi paradox questions why we haven't found evidence of alien civilizations despite the vastness of the universe. The universe is immense, with billions of galaxies, each containing billions of stars. Many of those stars have planets, and some of those planets should be capable of supporting life. Given the age of the universe, civilizations could have arisen millions or even billions of years ago, with plenty of time to spread across the galaxy. So where are they? Why haven't we detected signals, found artifacts, or encountered visitors? This puzzle is the Fermi paradox. Possible explanations include civilizations are rare. They destroy themselves before becoming spacefaring. They're too far away, or they're deliberately avoiding contact. We don't know the answer, and the silence from the stars is both humbling and unsettling. A reminder that despite our progress, we remain alone, at least as far as we can tell. Nuclear propulsion could dramatically reduce travel time to Mars and beyond. Chemical rockets are limited by the energy density of their fuel. Nuclear rockets, either fission or fusion-based, could provide far more thrust for far longer, cutting travel time to Mars from months to weeks. NASA and other agencies are researching nuclear thermal propulsion, where a reactor heats hydrogen to extreme temperatures, expelling it at high speed to generate thrust. The challenges are significant: building safe, reliable reactors that can operate in space, managing radiation, and developing the technology. But the potential benefits are enormous. Faster travel means less exposure to cosmic radiation, less time in microgravity, weakening bones and muscles, and the ability to reach distant destinations like Jupiter's moons or Saturn in reasonable timeframes. Nuclear propulsion could be the key to unlocking the outer solar system, making the dream of deep space exploration a practical reality. The Kessler syndrome describes a scenario where space debris creates a cascading chain of collisions. Earth's orbit is cluttered with defunct satellites, spent rocket stages, and fragments from past collisions. If the density of debris reaches a critical threshold, one collision could create a cloud of fragments that trigger more collisions, which create more fragments, spiraling out of control. This chain reaction could render certain orbits unusable, trapping humanity on Earth beneath a shell of deadly debris. It's not science fiction. The risk is real. Space agencies track thousands of objects, maneuvering satellites to avoid potential impacts. Efforts are underway to develop technologies to remove debris, but progress is slow. The Kessler syndrome is a warning, a reminder that space, despite its vastness, is a shared resource that we must manage carefully, or risk losing access to the stars we've worked so hard to reach. Astronauts described the overview effect, a profound shift in perspective after seeing Earth from space. From orbit, borders disappear. You see no nations, no walls, just a single fragile planet hanging in the void. Clouds swirl over oceans, continents drift beneath you, and the thin blue line of the atmosphere glows against the blackness. Many astronauts report that seeing Earth this way changes them, instilling a deep sense of connection and responsibility. They describe feeling protective, awed, and humbled. This phenomenon, called the overview effect, has been experienced by nearly everyone who's been to space. It's a reminder that despite our differences, we share one home, beautiful and delicate, and that the future of life depends on how we care for it. The view from space isn't just a privilege, it's a lesson, one that transcends language and culture, uniting us in wonder. The Chandrayaan missions have placed India among the elite nations exploring the moon. In the 2008, India's Chandrayaan-1 orbited the moon, mapping its surface and confirming the presence of water molecules. In 2023, Chandrayaan-3 successfully landed near the lunar South Pole, making India the fourth country to achieve a soft landing on the moon. These missions demonstrate India's growing capabilities in space exploration, carried out on budgets far smaller than those of other space agencies, yet achieving significant scientific results. Chandrayaan's discoveries have contributed to our understanding of the moon's composition and resources, informing future exploration plans. India's success inspires other nations to pursue their own space ambitions, proving that spaceflight isn't reserved for superpowers, but accessible to any country with the vision, determination, and ingenuity to reach for the stars. The James Webb Space Telescope's sunshield is the size of a tennis court and keeps the instruments at -233 degrees Celsius. Webb's instruments must operate at incredibly cold temperatures to detect faint infrared light from distant galaxies. To achieve this, the telescope is equipped with a massive, multi-layered sunshield that blocks heat from the sun, Earth, and Moon. This shield is made of ultra-thin material, each layer thinner than a human hair, but together they reduce the temperature on the shadowed side by hundreds of degrees. The telescope orbits at L2, positioned so the sun, Earth, and Moon are always on one side, allowing the sun shield to protect the delicate instruments on the other. This engineering marvel is essential to Webb's mission, enabling it to peer deeper into the universe than ever before, revealing secrets hidden in the infrared glow of the cosmos. Pluto was reclassified as a dwarf planet in 2006, sparking debate among astronomers and the public. For 76 years, Pluto was considered the ninth planet, but as astronomers discovered more objects in the outer solar system, some similar in size to Pluto, they faced a question. Should all of these be planets, or should the definition change? In 2006, the International Astronomical Union redefined planet to require that an object clear its orbit of other debris. Pluto shares its region with thousands of other icy bodies in the Kuiper Belt, so it was reclassified as a dwarf planet. The decision was controversial, with many people upset about Pluto's demotion, but scientifically, it makes sense. Pluto is still fascinating, a small, distant world with mountains of ice, a thin atmosphere, and a heart-shaped glacier. Its reclassification doesn't diminish its wonder, just our understanding of what a planet is. The human body produces more mucus in space because fluids shift toward the head in microgravity. On Earth, gravity pulls fluids downward, distributing blood and other liquids throughout your body. In space, without that pull, fluids shift upward, pooling in the chest and head. Astronauts often have puffy faces, narrower legs, and a stuffy nose, similar to a mild cold. This fluid shift can also increase pressure in the eyes, potentially damaging vision over long missions. The body adapts somewhat over time, but the effects persist. When astronauts return to Earth, gravity redistributes the fluids again, and the symptoms resolve. This is one of many subtle ways microgravity affects physiology, reminding us that our bodies evolved in a specific environment, and removing even one element like gravity creates a cascade of changes we're still learning to manage. The concept of a generation ship involves a spacecraft traveling for centuries, with multiple generations living and dying aboard. If we want to reach distant star systems with current technology, the journey would take thousands of years. A generation ship would be a self-contained habitat, a small world traveling through space, with enough resources to sustain a population for centuries. Children would be born, grow old, and die aboard the ship, never seeing Earth or the destination, living their entire lives in transit. It's a profound concept, a society adrift between worlds, preserving culture, knowledge, and purpose across generations. The challenges are staggering: maintaining technology over centuries, preventing social collapse, ensuring genetic diversity. But it represents one vision of humanity's future: a slow, patient journey to the stars, carried not by individuals, but by the collective will of generations. The SETI project searches for signals from extraterrestrial civilizations using radio telescopes. Since 1960, scientists have been listening to the sky, scanning radio frequencies for patterns that might indicate intelligent life. Most of what they hear is natural: pulsars, cosmic noise, electromagnetic radiation from stars and galaxies. But they're looking for something different: a narrow band signal, a repeating pattern, something that couldn't occur naturally. So far, SETI has found nothing conclusive, though there have been intriguing false alarms. The search continues, using increasingly sensitive instruments and sophisticated algorithms to sift through vast amounts of data. It's a patient endeavor, one that may never find an answer, but the mere act of searching is significant, a statement that we believe we might not be alone, and that the effort to find out is worth the time and resources, even if the silence continues. Europa, one of Jupiter's moons, has a subsurface ocean beneath its icy crust that may harbor life. Europa's surface is covered in thick ice, crisscrossed with cracks and ridges. But beneath that frozen shell, scientists believe there's a global ocean of liquid water, kept warm by tidal heating, as Jupiter's gravity flexes and squeezes the moon. Where there's liquid water, there's potential for life. Europa's ocean could contain more water than all of Earth's oceans combined. Future missions plan to fly through the plumes of water vapor that erupt from cracks in the ice, analyzing them for organic molecules or other signs of life. Europa represents one of the most promising places in the solar system to search for extraterrestrial life, a frozen moon hiding a vast dark ocean that might, just might, be teeming with strange alien organisms. The Apollo 13 mission became a successful failure when the crew survived a catastrophic explosion. On April 13, 1970, an oxygen tank exploded aboard Apollo 13, crippling the spacecraft on its way to the moon. The mission to land was aborted immediately. Instead, the crew, astronauts James Lovell, Jack Swigert, and Fred Hayes, faced a desperate fight for survival. They used the lunar module as a lifeboat, rationing power, water, and oxygen. Mission Control worked tirelessly to calculate trajectories and improvise solutions. Carbon dioxide levels rose dangerously, and the crew built makeshift filters from spare parts. Against the odds, they swung around the moon and returned to Earth, splashing down safely. Apollo 13 became a symbol of ingenuity, teamwork, and resilience, proving that even in the face of disaster, human determination can overcome seemingly impossible challenges. The solar wind is a stream of charged particles constantly flowing from the sun, shaping the magnetic environment around planets. The sun doesn't just emit light, it also releases a constant stream of electrons and protons, traveling outward at hundreds of kilometers per second. This solar wind interacts with planetary magnetic fields, creating phenomena like Earth's auroras. When solar wind particles strike our atmosphere near the poles, they excite atoms, causing them to glow in shimmering curtains of green, red, and purple light. The solar wind also poses a danger to astronauts and satellites, especially during solar storms when the flow intensifies. Understanding the solar wind is crucial for protecting technology and human explorers in space, and missions like the Parker Solar Probe are studying it up close, helping us predict and prepare for its effects. Mars has the tallest volcano in the solar system, Olympus Mons, standing nearly 22 kilometers high. Olympus Mons is a shield volcano, built from countless lava flows over millions of years. It's so large that if you stood on its slopes, the curvature would hide the summit beyond the horizon. Its base is roughly the size of Arizona, and its peak rises more than twice as high as Mount Everest. The volcano is likely extinct, its last eruptions occurring millions of years ago. Mars's lower gravity allowed it to grow so large, lava piling higher and higher without collapsing under its own weight. Olympus Mons is a monument to the dynamic geological past of a planet we often think of as dead, a reminder that Mars was once a world of eruptions, flowing lava, and dramatic change. The concept of panspermia suggests life on Earth may have originated from microbes carried by asteroids or comets. When asteroids collide with planets, debris is ejected into space. Some of that debris, carrying microbes trapped in rock, could survive the journey through space and eventually land on another planet, seeding it with life. This idea, called panspermia, suggests that life didn't necessarily originate on Earth, but might have arrived from elsewhere. There's evidence that certain extremophile bacteria can survive the harsh conditions of space for extended periods. If panspermia is true, life could be widespread in the universe, spreading from world to world on cosmic debris. It's speculative, but intriguing, blurring the line between Earth life and cosmic life, suggesting that we might all be descendants of ancient travelers from the stars. The Artemis program aims to return humans to the moon and establish a sustainable presence by the end of the decade. Named after the Greek goddess of the moon and twin sister of Apollo, Artemis is NASA's plan to land the first woman and next man on the lunar surface. Unlike Apollo, which focused on short visits, Artemis aims for long-term habitation. Plans include building a space station called Gateway in lunar orbit, establishing a base camp on the surface, and using the moon as a proving ground for technologies needed for Mars. The program represents international collaboration with contributions from Europe, Japan, Canada, and other partners. Artemis is ambitious, a step toward making humanity a spacefaring civilization, with the moon as the first permanent foothold beyond Earth. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. When a massive star dies, its core collapses under its own gravity, compressing matter into an infinitely small point called a singularity. Around this singularity is the event horizon, the boundary beyond which escape is impossible. Anything that crosses the event horizon is lost forever, pulled inexorably inward. We can't see black holes directly because they emit no light, but we detect them by their effects on nearby matter. Stars orbiting invisible companions, gas spiraling inward and heating to millions of degrees, emitting X-rays before it disappears. Black holes challenge our understanding of physics, places where space and time break down, where the rules we know no longer apply. They're terrifying and fascinating, cosmic monsters lurking in the dark. Astronauts aboard the ISS contribute to climate research by monitoring Earth's atmosphere, oceans, and land From orbit, astronauts have a unique vantage point to observe Earth's changing climate. They photograph storms, track deforestation, monitor glaciers, and observe ocean currents. Instruments aboard the ISS measure atmospheric gases, temperature variations, and other data crucial for understanding climate change. These observations complement satellite data, providing ground truth verification and capturing events satellites might miss. The perspective from space reveals patterns invisible from the ground, showing how interconnected Earth's systems are. Astronauts often become advocates for environmental protection after seeing firsthand how fragile our planet is. Their work in orbit doesn't just advance space exploration, it helps protect the world we're exploring from, providing critical information for addressing one of humanity's greatest challenges. The rings of Saturn are gradually disappearing, raining down onto the planet's atmosphere. Saturn's iconic rings won't last forever. Gravity and magnetic fields are slowly pulling ring particles inward, where they vaporize in the atmosphere, a process called ring rain. Scientists estimate that the rings could disappear entirely in about 100 million years, a blink of an eye in cosmic terms. This means we're living in a special time, an era when Saturn has rings. In the distant past, it might not have had them, and in the distant future, they'll be gone. Their transience makes them even more precious, a temporary beauty in an ever-changing solar system. Saturn's rings are a reminder that nothing in the cosmos is permanent. Everything evolves, everything fades, even the most stunning features of the worlds we love. The Moon's gravity is 1/6 of Earth's, allowing astronauts to jump higher and move more easily. On the Moon, an astronaut in a full suit can leap several meters with a single push, bounding across the surface in graceful, slow-motion arcs. Walking becomes more like hopping, and objects feel lighter, though their mass remains unchanged. This reduced gravity makes some tasks easier, lifting heavy equipment, for example, but it also creates challenges. Your inertia is the same, so stopping quickly or changing direction is difficult. Dust kicked up by footsteps hangs in the air longer before settling. The low gravity affects how habitats and vehicles must be designed, ensuring stability and safety. Experiencing 1/6 gravity is surreal, a constant reminder that you're on another world where the familiar rules of weight and motion have shifted, creating a landscape where movement feels dreamlike and strange. The WOW signal detected in 1977 remains one of the most intriguing potential signs of extraterrestrial intelligence. On August 15, 1977, a radio telescope in Ohio detected a strong, narrow-band signal from the direction of the constellation Sagittarius. The signal lasted 72 seconds and was so unusual that astronomer Jerry Eman wrote, "Wow," on the printout. It matched the characteristics expected from an artificial transmission, but it was never detected again despite repeated searches. No natural phenomenon has been found that explains it perfectly. It remains a mystery, possibly a signal from an alien civilization, or perhaps something more mundane we don't yet understand. The WOW signal captures the tantalizing possibility that we might not be alone. A brief whisper from the stars that hinted at something extraordinary, then fell silent, leaving us wondering. The development of reusable rockets by SpaceX has dramatically reduced the cost of launching payloads into space. Traditionally, rockets were single-use, discarded after each flight, making launches extraordinarily expensive. SpaceX changed that by developing the Falcon 9, a rocket whose first stage can land itself after launch, either on a drone ship at sea or on a landing pad. This stage can be refurbished and flown again, sometimes within weeks. Reusability has slashed costs, making space more accessible for satellites, research, and commercial ventures. SpaceX has now landed and reused boosters dozens of times, proving the concept works. This innovation is transforming the space industry, lowering barriers to entry and enabling new missions that would have been economically unfeasible before. Reusable rockets are a key step toward making space travel routine and sustainable. The surface of Mars is red because of iron oxide, essentially rust, covering the rocks and soil. Billions of years ago, Mars had a thicker atmosphere and liquid water on its surface. Iron in the Martian soil reacted with oxygen and water, forming iron oxide, the same compound that makes rust on Earth. Over time, as the atmosphere thinned and the water disappeared, the red dust remained, blanketing the planet. Winds carry this dust across the surface, creating vast dune fields and sometimes global dust storms that obscure the entire planet. The red color has fascinated humans for centuries, making Mars the red planet, a beacon in the night sky. That rust tells a story of a world that once had the ingredients for life, water, and chemistry, but lost them, leaving behind a cold, dry desert painted in shades of ochre and crimson. The International Space Station has been continuously inhabited since November 2000, over 2 decades of human presence in space. For more than 20 years, there have been people living and working above our heads, orbiting Earth in a metal and composite habitat. Crew members rotate every few months, arriving aboard Russian Soyuz capsules or American Crew Dragons. They conduct experiments, perform maintenance, exercise, eat, sleep, and occasionally step outside for spacewalks. The ISS represents an unprecedented achievement in international cooperation, with modules and components contributed by the United States, Russia, Europe, Japan, and Canada. It's a symbol of what humanity can accomplish when we work together, a small but significant foothold beyond our planet, proving that we can live in space, not just for hours or days, but indefinitely, as long as we maintain the will and the resources to support it. The Voyager Golden Records are phonograph discs carried by Voyager 1 and 2, containing sounds and images from Earth. In 1977, NASA launched 2 probes with a message for any intelligent life that might find them. Each Voyager carries a golden record containing 116 images, greetings in 55 languages, music from different cultures, and natural sounds like wind, waves, and animal calls. Instructions for playing the record are etched on its cover, along with a map showing Earth's location relative to pulsars. The records are a time capsule, a portrait of humanity at a moment in time, sent into the void with the hope that someday, perhaps billions of years from now, another civilization might discover them and learn that we existed. It's a poetic gesture, a message in a bottle cast into the cosmic ocean, carrying our voices to the stars. China's space program has achieved significant milestones, including landing the Chang'e 4 rover on the far side of the Moon. In 2019, China became the first nation to successfully land a spacecraft on the Moon's far side, a region never visible from Earth because the Moon is tidally locked. The Chang'e 4 mission deployed a rover, Yutu-2, which has been exploring the surface and conducting experiments. China has also brought lunar samples back to Earth, built its own space station, Tiangong, and sent robotic missions to Mars. These achievements signal China's ambition to become a leading spacefaring nation. The country's rapid progress demonstrates that space exploration is no longer dominated by two superpowers, but is becoming a more diverse global endeavor, with multiple nations contributing to our understanding of the cosmos. Astronauts use special pens that can write in zero gravity, extreme temperatures, and even underwater. The Fisher Space Pen was developed in the 1960s to solve a problem. Ordinary pens rely on gravity to draw ink toward the tip, and they don't work in space. The Space Pen uses a pressurized ink cartridge that pushes ink out regardless of orientation, and the ink itself is specially formulated to withstand temperatures from -30 to over 120 degrees Celsius. Contrary to popular myth, NASA didn't spend millions developing it. The inventor created it independently and then sold it to NASA. Astronauts use these pens for writing notes, logging data, and signing their names on the ISS walls. It's a small detail, but symbolic, showing how even the simplest tasks require rethinking in space, where nothing works quite the way it does on Earth. The Sun fuses 600 million tons of hydrogen into helium every second, releasing the energy that powers the solar system. Deep in the Sun's core, where temperatures reach 15 million degrees Celsius and pressure is immense, hydrogen nuclei smash together, fusing into helium and releasing energy in the form of light and heat. This process, nuclear fusion, has been ongoing for 4.6 billion years and will continue for another 5 billion. The energy produced travels outward from the core, taking thousands of years to reach the surface, then racing across space to warm our planet in just 8 minutes. Every ray of sunlight, every bit of warmth you feel, every photosynthesis reaction in every plant, all of it traces back to those fusion reactions deep in the Sun's heart. We owe everything to that distant furnace, a star that burns steadily, generously, giving life to the worlds that orbit it. The search for exoplanets has revealed thousands of worlds orbiting distant stars, some potentially habitable. In 1995, astronomers confirmed the first planet orbiting a sun-like star beyond our solar system. Since then, missions like Kepler and TESS have discovered thousands more, revealing a stunning diversity of planets, gas giants larger than Jupiter, rocky worlds smaller than Earth, planets orbiting binary stars, and some in the habitable zone where liquid water could exist. A few exoplanets have been studied in detail, analyzing their atmospheres for signs of water vapor, methane, or oxygen, molecules that might indicate life. We haven't found definitive proof of extraterrestrial life yet, but the sheer number of planets suggests that the conditions for life might be common. The universe is full of worlds, and some of them might be home to something other than us. The SpaceX Crew Dragon capsule autonomously docks with the ISS, demonstrating advanced automation in spaceflight. Previous spacecraft required manual piloting to dock with the station. A delicate, risky maneuver. Crew Dragon, however, can navigate and dock itself using sensors, cameras, and sophisticated software. Astronauts aboard monitor the process, ready to take control if needed. But the system works flawlessly, approaching the station, aligning with the docking port, and latching on with precision. This automation reduces the workload on crews and increases safety. It represents a shift in spaceflight, where computers handle tasks that once required human skill and reflexes. As missions become more complex and venture farther from Earth, automation will become even more critical, allowing spacecraft to operate semi-independently, making decisions and corrections without waiting for instructions from distant ground control. Mars has seasons, polar ice caps, and dust storms, making it the most Earth-like planet in the solar system. Mars's axis is tilted similarly to Earth's, giving it seasons: winter, spring, summer, and autumn. During Martian winter, carbon dioxide from the atmosphere freezes onto the polar ice caps, expanding them. In summer, the ice sublimes back into gas, shrinking the caps. Dust storms can start small and grow to engulf the entire planet, blocking out sunlight for weeks. These storms pose challenges for rovers and future human missions. Despite the similarities, Mars is harsher than Earth, with temperatures averaging -60 degrees Celsius, an atmosphere too thin to breathe, and no liquid water on the surface. Yet it's the closest we have to another habitable world, and that similarity fuels our desire to explore it, understand it, and perhaps one day transform it into a second home. The concept of mining asteroids for resources could provide materials for space construction and reduce reliance on Earth. Some asteroids are rich in metals like iron, nickel, platinum, and gold, resources that are rare on Earth, but abundant in space. Mining these asteroids could provide raw materials for building spacecraft, space stations, and habitats without the cost of launching them from Earth's surface. A single metallic asteroid could contain more precious metals than have been mined in all of human history. Companies and space agencies are studying how to capture asteroids, extract their resources, and process them in space. It's still speculative. The technology is in its infancy, but the potential is enormous. Asteroid mining could transform space exploration from a scientific endeavor into an economic one, opening the solar system to industry, commerce, and permanent settlement. The Hubble Space Telescope was repaired and upgraded 5 times by astronauts during spacewalks, extending its life. When Hubble launched in 1990, its primary mirror had a flaw, producing blurry images. In 1993, astronauts installed corrective optics, fixing the problem and transforming Hubble into the powerful observatory it was meant to be. Over the years, 4 more servicing missions replaced instruments, upgraded computers, and installed new cameras, each mission requiring intricate work in the harsh environment of space. These repairs kept Hubble operational for over 3 decades, far beyond its original design life. The servicing missions demonstrated the value of human presence in space, showing that astronauts can perform delicate, complex tasks that robots can't. Hubble's longevity is a testament to human ingenuity, determination, and the willingness to go into space and fix what's broken, keeping our window to the universe open. The Moon has no atmosphere, so there's no sound, no weather, and temperatures swing between extremes. Without air, the Moon is silent. There's no wind to erode rocks, no rain to carve valleys, and no weather to speak of. The lack of atmosphere also means no protection from the sun's radiation or from meteorite impacts. Temperatures on the lunar surface can reach 127 degrees Celsius in direct sunlight and plunge to -173 degrees Celsius in shadow. This extreme environment makes exploration challenging, but also offers opportunities. Lunar soil could be used for construction, and the lack of atmosphere makes it an ideal location for telescopes that can observe the universe without distortion. The Moon is harsh and unforgiving, but it's also a blank canvas, a place where humanity can learn to live beyond Earth, building habitats and technologies that will one day carry us farther. The study of space weather focuses on solar flares, coronal mass ejections, and their effects on Earth. The sun isn't constant, It has an 11-year cycle of activity, with periods of intense solar storms. During these storms, the sun releases massive bursts of energy called solar flares and ejects clouds of charged particles known as coronal mass ejections. When these reach Earth, they can disrupt satellites, interfere with GPS and communications, and even damage power grids. In 1859, a massive solar storm called the Carrington event caused telegraph systems to fail and sparked fires. If a similar storm hit today, it could cause widespread blackouts and disable technology. Scientists monitor the sun constantly, watching for signs of eruptions, trying to predict when they'll occur and how strong they'll be, working to protect the technology and infrastructure our modern world depends on. The Artemis Accords are international agreements establishing principles for peaceful lunar exploration. As more nations and private companies plan to explore the moon, there's a need for guidelines to prevent conflict and ensure cooperation. The Artemis Accords, initiated by NASA and signed by multiple countries, outline principles like transparency, interoperability, peaceful use of space, and the safe disposal of debris. They also address resource extraction, allowing nations to use lunar resources while respecting international law. The Accords aren't a treaty, but a set of shared values and commitments designed to foster collaboration and prevent disputes as humanity returns to the moon. They represent an effort to ensure that space exploration benefits everyone, conducted openly, responsibly, and peacefully, setting a foundation for sustainable presence beyond Earth. The universe is expanding, and distant galaxies are moving away from us faster than the speed of light due to the expansion of space itself. This seems to violate the cosmic speed limit, but it doesn't. The galaxies aren't moving through space faster than light. Space itself is expanding, carrying them along. Imagine dots on a balloon. As the balloon inflates, the dots move apart, not because they're traveling across the surface, but because the surface itself is stretching. The farther away a galaxy is, the faster it appears to recede, because there's more space between us expanding. Eventually, galaxies beyond a certain distance will be moving away so fast that their light will never reach us, creating a horizon beyond which we can never see. The universe's expansion is one of its most profound mysteries, a reminder that the cosmos is dynamic, ever-changing, and far stranger than it appears. The first untethered spacewalk was performed by Bruce McCandless in 1984, using a jetpack called the Manned Maneuvering Unit. Before McCandless, astronauts on spacewalks were always tethered to their spacecraft. But on February 7th, 1984, McCandless floated away from the space shuttle, propelled by nitrogen jets, becoming the first human to fly freely in space. He traveled over 100 meters from the shuttle, a tiny figure against the blackness, untethered and alone. The Manned Maneuvering Unit gave astronauts the freedom to move independently, performing repairs and retrievals without being anchored. It was exhilarating and terrifying, a moment of profound isolation and freedom. Though the unit is no longer used, that first untethered spacewalk remains iconic, a symbol of human daring, the willingness to step into the void with nothing but a jetpack and trust in technology. Humanity's farthest reach into space is still within our own solar system, yet interstellar travel remains a distant dream. The Voyager probes have traveled farther than any human-made object, but even at their speed, they won't reach another star for tens of thousands of years. Interstellar travel requires speeds we can't achieve with current technology, Ideas like nuclear pulse propulsion, antimatter engines, or light sails powered by lasers offer theoretical possibilities, but building them is beyond our current capabilities. The distances are staggering. Even the nearest star is over 4 light-years away, and with our fastest spacecraft, the journey would take millennia. Yet the dream persists, and scientists continue exploring concepts, designing ships that could carry us beyond the sun's influence. Interstellar travel may be centuries away, but it represents the ultimate frontier, the final step in humanity's journey from Earth to the stars. The Moon has valuable resources, including helium-3, which could potentially fuel future fusion reactors. Deep within the lunar soil, a rare isotope called helium-3 has accumulated over billions of years, deposited by the solar wind. On Earth, helium-3 is extremely rare, but the Moon's surface contains significant quantities because it has no atmosphere to block the solar wind. This isotope could be used in nuclear fusion reactors, producing clean energy with minimal radioactive waste. While fusion power using helium-3 is still theoretical, the potential is enormous, enough to power human civilization for centuries. Mining the Moon for helium-3 would require significant infrastructure, habitats, processing plants, and transport vehicles. But the reward could be energy independence. The Moon isn't just a destination for exploration. It might become a source of fuel, transforming it from a barren rock into a valuable resource that helps sustain humanity's future. Astronauts experience about 16 microgravity-induced immune system changes, making them more susceptible to illness in space. In microgravity, the human immune system doesn't function as effectively as it does on Earth. White blood cells behave differently. Their ability to fight infections is reduced, and dormant viruses like herpes simplex can reactivate in astronauts' bodies. The stress of spaceflight, radiation exposure, and altered sleep patterns further compromise immunity. Crew members on the ISS sometimes get sick, and treating infections in space is complicated because medications may not work the same way. Scientists are studying these changes to develop countermeasures, medications or treatments that could protect astronauts on long missions to Mars or beyond. Understanding how space affects the immune system isn't just important for space travelers. It also provides insights into immune function on Earth, potentially leading to new treatments for immune disorders and diseases. Thank you for joining me tonight on this gentle journey through the history and future of space travel. From the first rockets that touched the edge of the sky to the dreams of distant worlds we've yet to visit, humanity's reach into the cosmos tells a story of courage, wonder, and an unshakable desire to explore. As you drift towards sleep, let these stories settle softly in your mind, reminding you that the universe is vast, beautiful, and waiting. If you enjoyed this journey, please consider subscribing to the Cozy Curiosity channel, where curiosity meets calm every night. Sleep well, stay curious, and may your dreams carry you gently among the stars. Good night.